Now let's say if I quickly summarize the OSI model. So OSI model is having 7 layers, and those are named as physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. Start with the physical layer. So physical layer is responsible for transfer of bits, that is ones and zeros. It represents the physical medium which is carrying the traffic between two nodes. So physical medium can be wired, or it can be Wi-Fi, or you can say the wireless. It can be, fiber optics. That is also wired, but here I'm specifically talking about the wired Ethernet. Here, bits are transformed in the form of signal, or you can say the electric signal. So I'm just writing electric signal. So here bits are transferred in the form of signal. Here bits are transferred in the form of radio signal. Here bits are transferred in the form of light. The devices repeater and hub also operate at this layer. So we had in the previous lecture we had talked about the repeater and hubs. So hubs and repeater are actually operate at this layer. A repeater is simply represent a signal from one medium to the other to increase the range of the signal, so that uh, it can be transferred beyond the signal cable limit, where a hub is simply a multi-port repeater. Now next would be the data link layer. So data link layer actually interface the physical layer, or you can say between the network layer and physical layer there is an interface we call the data link layer. uh, the 0 को वायर तक पहुंचाने का काम आपका किसका है? डेटा लिंक लेयर का है. Once there is a medium coming to picture, then that is a functionality of physical layer. So data link layer first of all interface with the physical layer. Number two, it serves the responsibility of putting ones and zeros on the wire. And similarly takes the values, or takes ones and zeros from the wire. Here network interface card plug to Ethernet wire that handles the layer 2 functionality. Okay, so here one device which we call the network interface card that is being used at the data link layer, which actually plug to the Ethernet wire and have perform the layer 2 functionality. It receives the signal from the wire and transmits the signal on the onto the wire. Wi-Fi NIC does the same. अगर हम Wi-Fi की बात करें, Wi-Fi network की बात करें, if it is not a wired network, if it is a Wi-Fi network, then also there would be a device that is Wi-Fi network interface card. We call it Wi-Fi NIC, and it does the same receiving, that is receiving and transmitting the radio wave. And the purpose of layer 2, as we already seen, that it is the host to host communication. Okay, which is so hop to hop communication will be provided. So if there is one host over here and there is another host, let's say, and in between if there are multiple routers, so the data link layer functionality of data link layer is having communication from this hop to next hop, and then next hop to its next hop, then next to its next, and so on. Okay, so layer 2 then group together ones and zeros into chunks with what we known as frame, or you can say at the stage of data link layer, the construct what we have concluded here is called as frame. So layer 2 data is nothing but a frame. There is an addressing system at layer 2 that is known as the MAC addresses. The MAC addresses uniquely identify each individual network interface card. Each NIC is pre-configured with a MAC address, also known as burned-in address. Okay, so it is something which is going to be assigned at the time of manufacturing. Now, aside from NIC, a switch also operate at this layer, responsible to facilitate communication within the network. So I can say, apart from the NIC, a switch is also going to operate at this layer, and the responsibility, or you can say the goal of this data link layer, is to deliver packets hop to hop, that is one NIC to another NIC. So whenever we are talking about the MAC address, we are actually talking about the NICs, we are talking about the data link layer, we are talking about the hop. Okay, then next comes the network layer. At this layer 3, we have the data construct we called in terms of packets. Okay, so जो data link जो आपका data link layer पे frame हुआ करता था, that is you know uh, the construct which was created at data link layer was called as your frame, while the construct which is created at the network layer is called as packet. So network layer actually responsible for packet delivery from end to end using IP addressing. So it is responsible for packet delivery from end to end using IP addressing scheme. IP address is nothing but the logical address which is actually not the permanent. MAC address is a permanent permanent address, okay, which is not going to change further but IP addressing is the logical address, and that logical address is not permanent. A router is used to facilitate communication between the network, and the router is going to use, or you can say the device which is used at this layer is nothing but the router. And router is nothing but to facilitate a device which facilitate communication between the networks. Now, if we talk about the, we just differentiate over here between the layer 2 and layer 3. So first of all, what here we have understood the two addressing schemes. One is MAC address and another one is IP address. So layer 2 uses MAC address and is responsible for packet delivery hop to hop, and layer 3 uses IP address which is responsible for packet delivery end to end, or you can say the source to destination. So here layer 2 versus layer 3, we have seen layer 2 uses MAC address, layer 3 uses IP address, layer 3 2 uses switches, layer 3 uses routers. Layer 2 is having the goal which is delivery, delivery hop to hop, and layer 3 is having goal which is delivering or communication end to end. In other words, we can write it source to destination. Okay, or you can say the device to device. Now, let's quickly understood that, let's say this is the host 1 which actually wants to communicate to this host 2, and let's suppose there are 3 routers in between. Now, whenever the application layer of this host 1 is creating the data, further at transport layer 1 header information is being added, and uh, this construct is known as segment. So this is header of transport layer, you can say, that is being added to this data, and then next it is going to be sent to the network layer. For the network layer, it doesn't matter what the header of transport layer is. It will include, it will assume that this is nothing but a 01 data, chunk of 01 data, और उसके अंदर जाके वो नहीं देखने वाला है कि वो उसमें हेडर कौन सा है और एक्चुअल डेटा कौन सा है. For the network layer, this whole header plus data, or you can say this is the payload, which is nothing but the data, और इस पे नेटवर्क लेयर अपना एक हेडर अटैच करेगा, and then this is further going to send to this whole uh, payload is going to send to the data link layer, which is also not going to differentiate between the header and data, and is actually not going to get into the detail of it, and it will assume this whole payload as a data for that layer. So this whole data will be suffixed by the header of data link layer. Here, then this data link layer, the data link layer also add the one trailer information also along with the header. Okay, that we will talk about later in the data link layer. Okay, then this data link layer put this 01 sequence of data on the wire, and then it is going to send to this router by router. This information or this data can be sent. Now, to go specific, as of now I'm not talking about the transport layer till now, but if we talk about The header information which was the added by the network layer, it contains the source IP address and destination IP address. So header of network layer contains source IP and destination IP address. Similarly, the header of this data link layer contains both source MAC address and destination MAC address. This destination MAC address is nothing but the address of the next hop, while this destination IP means the IP address of the actual host, or you can say the destination host. Okay, so you can see over here that if this data from the H1 machine wants to send the data to this S2 machine, first of all, this is going to, this data with IP addresses, source IP address and destination IP address, and then source MAC and destination MAC address is going to be sent to the next hop. Here, this is the MAC address of the next hop, which is the, this is R1 router, this is R2 router, this is R3 router. So here the MAC address or destination MAC address would be the MAC address of router 1, and once the data is received to the router 1, MAC address of router 1, this router actually removes the MAC address, its own MAC address, and will add the MAC address of R2. Then this will reach to the router 2, and at the router 2 level, router 2 will remove the MAC address of router 2 and will add the MAC address of router 3. So it will remove MAC address of, first it will remove the MAC address of R2 and then will add MAC address of R3. Then when the data will reach to this router 3, it will remove MAC address of router 3 and will add MAC address of the interface, or you can say the NIC of H2. And hence the data will reach to this machine H2, and it will remove, first it will remove the data link layer of this machine, will remove the MAC address of H2, and then after confirming that this is the host IP address, oh sorry, destination IP address through to which this data is intended to communicate, then network layer of this machine will remove the IP address header also, or you can say the network layer header. Then the further data is going to send to the transport layer, and then transport layer will remove its the header, transport layer header, which was having the information of uh, source port address and destination port address. So this is how it is going to, the data is going to reach in the from one host to another host. So here we can see IP address handles end-to-end delivery, and each of four different MAC address headers involved handling of hop to hop delivery. Now coming to the transport layer. So many services are possibly running on the host machine, as we have already discussed. Like a music player can, a chat application, and email can be run simultaneously on a host machine. Each of these applications are sending and receiving data from the internet, and all that data is arriving in the form of zeros and ones to that computer's NIC. Something has to exist. Now we can say that something has to exist in order to distinguish which ones and zeros belong to the messenger or the browser or the streaming music. That means if in a host machine there are multiple applications are running. Let's say this is application 1, this is application 2, this is application 3, application 4, many more you can understood. So if a sequence of zeros and ones are coming at the NIC of this machine, now this how much data is for intended for the application 1, what data is intended for application 2, what data is intended for application 3, and so on. So this information actually we require the some functionality to be accomplished here, and which is the transport layer. And transport layer provides or you can say the accomplish this by using an addressing scheme used as port number. So here two types of network two methods of distinguishing network stream are possibly here. One is UDP, which is user datagram protocol. Another one is TCP, which is transmission control protocol. UDP and PDP as of UDP and TCP are as of now we can differentiate in this manner only, that TCP is something which is a reliable protocol and UDP is something which is faster delivery. So both TCP and UDP have 0265535 port numbers, and a unique application stream is identified by both source and destination port. So here we can see the transport layer is responsible for service to service delivery by mean of service, that is application to application delivery. Now next, the session layer, presentation layer, and application layer. Practically all these layers are merged together into the same application layer. Now we will see that the concept of encapsulation and de-encapsulation. As we have already seen, that what do you mean by the encapsulation is how data is moved through the layers from top to bottom when sending, and from bottom to top when receiving. So this is what the concept of encapsulation and de-encapsulation. Here you can see the data. There are 7 layers on a machine. This is the application layer, presentation layer, session layer, transport layer, network layer, then data link layer, and then physical layer. Now the data is being created by the application layer, and will send to the presentation layer. Then presentation layer will add its own header and will send the data, or you can say the payload, or you can say the construct, to the session layer. Session layer will add its own header information to that payload, what he has received from the presentation layer, and will send the data to the transport layer. Transport layer will append its own header information, which is having the port number, source port number, and destination port number, and will send the data to the network layer, and the network layer will add its own header, which is having the information of source IP address and destination IP address, and then it will send the data to the data link layer, and the data link layer will add its own header and trailer information it adds for the checksum kind of thing, which is for error control. We will see that part in later, and we'll add the header information, which is having the source MAC address and destination MAC address, and finally this is going to be put on the wire in the form of 0 1 1 0, any the sequence of 0 and 1, and once it will receive to the host machine, another host machine. Okay, so the 1 and zeros will be received by the physical layer of this machine, and by looking at the destination NIC, sorry, destination address of the NICs present over there, it will, if it is so, then it will remove that header what is being added by the data link layer of this host. Okay, so I can say the source, I would say source and destination would be the good word over here. So the header information added by the data link layer of the source machine will now be removed by the data link layer of the destination machine. Similarly, the after removing the MAC address, you can say MAC address, or you can say the destination MAC address from this data link layer from the packet, it will send the data to the network layer. Network layer will see the header information appended by the network layer of source machine now will be removed by the network layer of the destination machine, and will send the data to the transport layer, and transport layer will see the by looking at the header of the transport layer attached by the transport layer of source machine will now be observed that for which application this data is being intended to, and will send that data to that application, and the header information is being removed here. And so you can see this is the process of attaching the information along with the data is called your encapsulation, while here at the receiver end we are actually removing the data part, or removing the added information part. Okay, which is the term called we as de-encapsulation. Now we will quickly see the devices, which are two important devices, switches and router. So switches nothing are nothing but to facilitate communication within the network. Okay, switches actually operates at the layer 2 of the OSI model, that is they only look into each datagram up to the layer 2 header. The layer 2 header contains information that enables hop to hop delivery, such as source and destination MAC addresses. And now the switches maintains a MAC address table, which actually map the MAC address of devices plugged into each switch port. A typical switch has many ports from 24 to 48 up to 96 or more. And MAC address table is populated by looking at the source MAC address, uh, in the field of any received frame. In order to forward the packet, or sorry, in order to forward the frame, because we are at the layer 2 as of now, In order to forward the frame, the switch will look up the destination MAC address in the MAC address table to determine which port to use. If switches encounter a frame for which it doesn't know the location of the destination MAC address, it will simply duplicate and flood the frame out to each switch port except the port it was received on. That means, if there is a switch and it doesn't have in its table, in its own table, it doesn't have the destination MAC address. It will simply, what it will do, it will duplicate the, or you can say the broadcast, or in other words, it will flood the frame out to each switch port except the port it was the data to from the port it was received on. Okay, so except this, the to the rest of the every port it will flood it. Okay, next is the router. Router is nothing but a device to facilitate communication within the between the networks. So it facilitates communication between networks. And here we can say that each interface on the router create a network boundary, and we can apply security, we can apply filtering option at the network boundary, because that is network boundary is the best place to apply such thing. Now router operate at the layer 3 of OSI model. That is, you can see over here, if we have one host, it is having all the 7 layers. So I'm just writing 1, 2, 3. Okay, 1 by means physical layer, 2 is data link layer, 3 is network layer, 4 is transport layer, 5th is session layer, 6th is presentation layer, and 7th is application layer. So all these layers are here, and then let's say this host is connected to a switch, and it is having a network 11.11.11.x. Now this when the information, any sequence of bits is going to send over this network, every host is having its own MAC addresses and its own IP addresses. So let's say this is double IP address 10.10, that is 11.11.11.10, and this is connected to a switch which actually operate on only on the 2 layers, because switch is a data link layer device. Then data from the host 1 is going to send to this switch is having the MAC address table, and by looking at the MAC address table, it is going to decide to which MAC address the data is next going to send, and that MAC address would be the destination MAC address, or in other words, that would be the MAC address of the next hop, or you can say the MAC address of the NIC of this router 1. And as because this is the router which actually operate on the network layer, or you can say this is a 3 layer, so it will operate on the all the 3 layers. Okay, that is physical, data link, and network. So router is a network layer device, so hence it is operating on these 3 layers. Again, there would be further a network which is a network of routers in between. So let's say this is something 20.22.22.x. So this is the IP address of this this network, and let's say the interface, this was the interface which was actually having some IP addresses of this network, and this is again the this is again, let's say, is having IP address, let's say 254, it is dot one. So the interface which is connected to this network, let's say I name it network one. So network one, the interface is having the IP address is 111.11.11.1, and the IP address of this interface which is actually connected to this network is nothing but 22.22.22.254. Similarly, it is further connected to a router which is router 2, and what now, the once the packet is received to the router 1 will uh, remove the MAC address of the uh, destination MAC address, and now we'll add the destination MAC address as the MAC address of the router 2, and in the same fashion this keeps going on, and this router is also connected to this. In between there can be multiple routers, okay, and then this router know that through this interface it is connected to the machine which is having the IP address of actual destination IP address, so which is nothing but, let's say, dot 20. So this is the IP address of this machine, and here in between there can be switch. So this router will send the data to this switch, and which is actually intended for the machine dot 20, and this here the process of de-encapsulation will going to happen. Here it is the process of encapsulation is going to perform over here. Here you can see that router 1, router 2, any router, if there are in between, then all those router are running on the three layers, which is the layer number 1, 2, and 3, and hence it is called the network layer device. So now coming to the switches, switches are facilitate communication within the network, and this is the network of this switch 1, and in this the switch is layer 2 device, and it will operate on the two layers only. So you can see over here that left interface of R2 here and right interface of R1 is nothing but are on the same network. Okay, and maintaining a routing table actually maps every network that actually exists over this network. So you can say R1 and R2 having the routing table, which are actually having the information of all the routers which are connected to this network. So if a router receive a packet destined to a network it doesn't know, then that packet is discarded. While in case of switch, if it doesn't know if a frame is destined to a MAC address which the MAC address table of switches doesn't know, then the switch is going to duplicates and flood that frame out to each switch port. So इस स्विच से जितने भी कनेक्टेड होंगे आपके होस्ट उन सबके पास वो चला जाएगा, जबकि राउटर के केस में क्या है, इफ router does not have the packet IP the you can say if router does not have the information of the destination network, then it will discard the packet. Now there is one more thing which we have discussed, which is ARP protocol, or you can say the address resolution protocol. So ARP is nothing but a bridge. It is a protocol which actually bridge between layer 2 address and layer 3 address. That means it bridges MAC address and IP addressing. So ARP will use the known IP address and discover unknown MAC address. So with the help of ARP, we can find MAC address of a machine for which we have already known the IP addresses. Now, for example, let's say uh, initially we have taken an example. Let's say we have one network over here, another network over here, and let's say in this network, let's say we are in India, and if a host is trying to connect to the server of Google, so it will simply write www.google.com. And as because the Google server is in the US, then a destination MAC address, destination IP address will come, the IP address of the server present in this US network. But the host over here doesn't know the IP address of this Google server, so it will simply write in the search option URL option www.google.com, and this actually information uh, you know will use the DNS server, which is nothing but the domain name server, which is going to actually help in extracting the IP address of this particular domain. Okay, so you can say that this w from this www.google.com, the IP address can be extracted through the DNS, and this is known as this is how IP address is known to a client. So initially destination IP address पता नहीं था, लेकिन DNS की हेल्प से क्या हुआ, जस्ट बाय राइटिंग द यूआरएल आपका डीएनएस पे आपकी क्वेरी गई जो कि डीएनएस पे गई, और डीएनएस ने आपको रिवर्ट बैक किया कि इस यूआरएल की करस्पॉन्डिंग जो आईपी एड्रेस है वो ये है, और उसका यूज़ करते हुए नेटवर्क लेयर में जब आप सोर्स आईपी एड्रेस और डेस्टिनेशन आईपी एड्रेस पुट कर रहा होगा ये मशीन, तो यहाँ पे ये क्लाइंट जो है उस तरह से उस आईपी एड्रेस का इस्तेमाल कर सकता है। तो दैट यहाँ पे ये तो चीज़ है वही कि आईपी एड्रेस, डेस्टिनेशन आईपी एड्रेस तो मिल गया। Now to discover the MAC address, for because at the layer 2 level there would be a need of source MAC address and destination MAC address. So now to find out the destination MAC address, we must need something to know the MAC address of the destination machine, and for that uh, you know we have the ARP table. So now we can say that the discovered MAC address is now being mapped to and stored in the ARP table, which is a mapping of IP address to the correlating MAC address. Here you can see that once we got the IP address of the destination machine, now ARP table will be updated with the MAC address of this machine and the IP address of that machine. So ARP table maintains the mapping between the IP addresses and the MAC addresses. So you can see this is what the ARP does. Now let us further see a little bit of it. Let's say it is a client. It is having the network. So when a client, let's say this is the client, is seeking info, or you can say is speaking to the host in the same network. For example, let's say S1 is nothing but the server, and there are two servers, S1 and S2, where S1 present in the same network and S2 present in a different network. And clients want to communicate. Let's say first time the, or you can say in first example, we can see that when the client is speaking to the host in the same network, or you can say the server one, then the client will issue an ARP request for the IP address of the host. Okay. When a client is speaking to a host in the different network, which is the S2, as because S2 is present in a different network, then the client will issue an ARP request for the IP address of the default gateway, and which is this. That means for the first condition, when within the network, see what is going to happen. This router is not going to come into picture until unless the data is going to send from this outside this network. So if both client and server reside on the same network, then whenever the client needs to communicate with the S1 server, which is in the same network, then the client will issue an ARP request for the IP address of this, you know, for the IP address of this machine. Okay. Then but if we talk about that, if this if the client is trying to communicate with the machine within which is on the different network, okay, then client will actually issue an ARP request for the IP address of default gateway. And what would be the default gateway is nothing but the interface of router 1 which is connected to this network. So as because अगर हमें डेस्टिनेशन मैक एड्रेस चाहिए, तो वहाँ पे डेस्टिनेशन मैक एड्रेस डायरेक्टली S2 का नहीं होगा, बल्कि बिकॉज दिस इज द मैक लेयर 2 कॉन्सेप्ट. सो लेयर 2 में आपका यहाँ क्लाइंट 1 से डेटा किसके पास जाएगा, राउटर 1 के पास जाएगा. दैट इज हॉप टू हॉप, then router 1 to router 2, then router 2 to this switch, or you can say to this machine. Okay, so you can see here that it is something what is hop to hop. And in case of within the network case, we have something, the packet would be something like this would be the data. Then at the layer 3 level, there would be source IP and destination IP. In the source IP is nothing but the client's IP, which is this, and destination IP is nothing but the S2 S1's IP, which is the IP address of S1. Similarly, at the layer 2 level, source MAC address is nothing but the client MAC address, and destination MAC address is nothing but S1's own MAC address. While in case when the data is coming out from one network to another network, then it is something between network. In such case, the layer 3 information which is being added would be again source IP and destination IP. Source IP is nothing but the client IP address. Destination IP address is nothing but the S1's IP address. And as far as the layer 2 data is concerned, the source MAC address would be the client MAC address, and source sorry and the destination MAC address at layer 2 would be the MAC address of S1, oh sorry, R1, which is router 1. So this is what the general specification of ARP. We have seen the DNS, we have seen the all the layer 1, layer 2, layer 3, layer 4, and how the communication is being established when the host is in within the network or when the host is outside the network. So this is what the overalls, in a brief, we have seen the OSI layer. Now we will further see the rest of section in the next lecture. Thank you.